During one of my lectures for Chapter 2 in your textbook, I had a guest speaker come in from Northwestern Michigan College. Dan Wasson is the director of our Systems and Land Management Group. And Dan came in to talk to my class about the enterprise solutions such as failover clustering, virtual desktop, um, other options including the ability to view basically reporting of all of our equipment, some sort of monitoring and management system. And Dan came in to talk about these enterprise solutions that the college, Northwestern Michigan College, uses in their environment. So Dan brought in several different diagrams, and we spent a little over an hour discussing and learning about how the college itself uses these different services. So the video that you're about to hear is from Dan coming into the classroom.
So I do recognize a few faces, but just out of curiosity, how many have been in one of Scott's classes where we've done the tour down in the data center, based East Hall? Okay, it's going to make this a whole lot easier. A lot of this, depending on how long it's been since you've been on the tour, you've either seen all of this or a chunk of this. But this is the core of our network system in the 5 data racks that we have there. I thought I'd start with is just a bit of the overall configuration, capacities, and different uses. At the far end in rack 0 is where all of our storage area network equipment resides. We're using compellant gear. We've actually just made a pretty big increase in our capacities and different equipment there for a VDI project that we're working on that I'll talk about in just a few minutes. But in our primary rack, we've got 3 different types of storage. We've got 15K fiber channel drives. You see those about halfway down the rack. There's a couple shelves of those. We've got a total of 22 drives for about 10 terabytes, 9.9 terabytes. The largest type of drive we have are the 2 terabyte, either SAS or SATA drives. We've got a total of 42 of those in there for 84 terabytes. And the latest thing that we added is SSD drives. We put in 400 gig SSD drives, and that's in the bottom 2 shelves. 32 of those total for just shy 13 terabytes of SSD. The SSD piece and some of the 7K SAS piece we added for the VDI project. The other aspect of our storage actually sits down in the data center downstairs here. This is where our DR, our backup SAN is, and it's another compellant SAN like this. It has another 42 2 terabyte SATA drives, so 84 terabytes downstairs as well. That makes up well, I was going to say the lion's share, but really that makes up all of our storage systems for everything for our infrastructure. As you remember from our discussion in East Hall, NMC has a central data center. Basically everything's there. It doesn't matter what campus you're on. Everything's going back to East Hall. Everything resides there. The other 2 large components of this would be our server infrastructure. We've got, we're using VMware as our virtualization platform, and we actually have 2 different VMware installs running. We have 10 different servers you'll see throughout the diagram called vhost servers, vhost 1 through 10. We don't get real creative with our names, but vhost 1 through 10. That server infrastructure is what we use for all of our, basically your file shares, anything is virtualized, Moodle, and most everything we do is virtualized. But all of that resides on our vhost system. The other system...
Physical boxes. Okay, so
correct. You see them right here. Here's vhost 10.9.8. You got Seb, you got a few of them here. I can't really read them on screen, but they're also scattered through the rack, and I'll talk about that in just a couple minutes. But they are the physical boxes. 10 physical boxes. Right now we've got about 120 virtual servers residing on those 10 physical boxes. In reality, as we stand here today, it's 8 boxes because vhost 1 and vhost 5 aren't online yet. We're in the process of replacing those. We pulled out 2 older ones, put in 2 newer ones. So as we stand here today, we're running on 8 out of the 10 boxes.
What kind of a process is that now that these things are really appliances connecting to your storage fabric, that kind of stuff?
It's a little bit of work. If you talk to Bryce and Neil, it's a lot of work. No, it's a little bit of work. The configuration of our virtual servers, our vhosts, is there's no hard drive infrastructure on the machines. These are all SAN boot devices. So the only thing we've got in there is processor RAM, really, and the other pieces. So when it's time to pull out, put new ones in, a lot of the work is already there. There is still a fair amount of work getting it ready, getting the ESXi set up and running and whatnot, but it's far less than if we were relying on server boot or server storage, server boot.
So all the configuration, I mean, do you just kind of turn it on and it boots from storage and the configuration is already basically there?
As long as Bryce never listens to this. Yeah, I mean, it's not quite that simple, but it is far simpler. There's a lot less that has to go on to get that up and running. And that's the same on the VDI servers, the 12 VDI servers that are there. Those are all SAN boot as well. No hard drives in those at all. Again, just it makes the box. It doesn't matter. It's inconsequential. It really is just an appliance at that matter.
That's interesting, especially considering how often the book harps on same hardware, same BIOS, same configuration, same everything. When you're swapping out physical machines to get back into the cluster configuration or whatever, is that you have to think that comes into.
It does and it doesn't.
Yeah.
IoT is more forgiving when it comes to the type of physical machine that's been used to host part of the cluster. So it's not as, and understand, you can have, I know this is confusing. It's confusing to me at times. There are different ways that you can implement clusters. You can implement a cluster across the 2 physical boxes.
Yep.
But you can also then implement a cluster over the VMs themselves. So the VMs can fail over and not necessarily lose a physical host. Or the VM could be, you could have one VM on one physical host, one VM on another physical host, and have clusters for the physical machines, clusters, what's called a guest cluster for the VMs.
Yep.
And if the physical host dies, it will migrate that virtual machine over to another physical host. And if you are doing clustering at the host level, or excuse me, at the VM level, it may add it as a node someplace else. So you could actually still have your cluster running on that VM on 2 different machines, even though you lost the host it was originally on. Sure. Once you replace that back up, then it's your choice to move it back. VMware is more forgiving when it comes to looking at hardware, and as he'll talk about in a little bit, the way in which it configures where these hosts go when we have a failure.
Our first venture into clustering 15 years ago now was hardware clustering, server clustering. Server, one server fails, the other server kicks in. While that was far better than individual servers that weren't connected or interconnected in any kind of clustering, the changes from that to what is here is light years different. in complexity as well. The hardware on the VDI side, on our 12 VDI servers, that is same hardware, but it's only because we bought it all at the same time. As far as our vhost 10 vhost servers, I would hazard that we have at least 4 different ProLiant DL385 models running there, and could have 5 different models. I'm not real sure right now. So the hardware dependency is nowhere close to what it used to be.
When you said VDI, you get what you're talking about, right? Or no?
Virtual desktop. Thank you, Scott. Virtual desktop. Something, yeah, it's something totally different.
It's a project NMC wanted to be able to do. So when you log in, you get a virtual desktop that's not necessarily the physical OS that you see on your machine. So we're using thin types of devices that when you log in, it looks at your profile, who you are, and sends down a virtual desktop specifically for you. So we're doing
Yep.
that in conjunction with TCAPS for a number of projects, and they implemented and invested a huge amount of infrastructure for that to happen. And so that's what he's referring to.
So far, our test and our pilot rollout has worked very well. We've got it running right now in production for the public computers in the Austin Library for 0113, where they do library instruction classes, mostly with the communications department. We've deployed it into the tutoring lab in the library, and we're working on our next phases of deployment, which will be University Center and a couple labs in Scholars Hall, and a couple other smaller places as well. The second piece of that they're working on is getting the connection between NMC and TCAPS, so that they'll be able to get into the VDI arena over there. NMC's first approach in VDI is the lab or the classroom, and for us, those systems, the VDI configuration is going to very closely mimic what the desktop computer configuration. Most all of our computer classrooms, they're frozen. So basically any changes that are made to the system, as soon as you turn them off, those are gone. In the VDI world, it's called non-persistent desktop, and that's how we're setting up our classrooms. TCAPS, because they want to put it into their employee stations and still have it closely mimic a desktop configuration, we have to go with what's called a persistent desktop, where you get a small amount of storage space on the SAN for your customizations. If you've got an application you want to install, it's exactly shortcuts, any of the personalization stuff. Not designed for, hey, I'm going to dump my music and my photos of vacation and all that other stuff. That's not what that's designed for, and the spaces will be small, so that doesn't occur. Where all that's going to reside, or where it does reside, is on the SSD. That's what that 13 terabytes of SSD is for, is to just provide fast response, fast access to that information that's there. Kind of the configuration that we've got running on both sides of the house, on the VDI side, we're running Dell PowerEdge servers for the VDI. They're R720s. Configuration is each one's got 2 processors with 8 cores. I had to flip back and forth here for a second. Two CPUs, or 2 processors, 8 cores each. We've loaded them out with 256 gig of RAM, and then we set up redundancies. We've got 2 NICs, 2 host bus adapters. Host bus, that's the connection, your fiber optic connection that you make into your SAN. 2 power supplies, and then something we had to add for this, because we're serving out the images, is we had to add some pretty beefy video cards. They're NVIDIA graphics video cards. Those things were a few $1,000 each on their own. And then we've got management on the servers. For Dell, they call it iDRAC. HP calls it ILO. Basically what it does, it's remote management, so we can remotely power on, power off, do different management administrative stuff, remote control, whatnot. Configuration on the vHost servers, a little bit different. They are all running dual processor. Between 6 and 12 cores, depends on the model and the age of the server. And between 64 and 128 gig RAM. Again, depends on the model and the age of the server. 2 NICs, 2 HBAs, 2 power supplies, and the ILO. That's the predominant configuration for the equipment that we've got in here. There are some other special devices that are physical in nature because of what they are, such as the banner server, which is where all of the information for running the business of the college is stored. All the student information, the financial accounting and whatnot, is processed on the banner server.
The ERP system, the Enterprise Research Plan.
This is a server without hard drives as well, so it's a beefy server, but still all the storage is up on the SAN. Relay server.
Yeah.
Okay, relay server. DNS servers, we kept those as physical devices. Special use, the point of sale system for Lobdell's restaurant, but very minor in compared to everything else that we've got there. As far as infrastructure, probably the biggest thing that we're concerned with and that you would be concerned with is how to deal with your redundancies, so you minimize your downtime and make failures inconsequential, really. So we've got different levels of redundancies for different pieces. We'd already talked about some of the server redundancies, the HBA, the host bus adapter, where that's making the host bus. Okay, let me go at this a different way. How is everything connected? Basically, we'll take any of the vHost servers, or any of the servers really. There are 2 fiber optic connections from the server to the switch at the top of rack 0. Those brocade switches, that's what's allowing the connection to go from, or making your connection from the server to your storage. For the redundancy, basically with the dual HBA, we'll take one connection from vHost 1 and put it into the top fiber switch. We'll take one connection from the other vHost 1 and put it into the second switch. So each one, oh, there you go. That's what it is. So each server is connected to 2 separate brocade switches. Any single failure on a brocade, everything would automatically go to flip to the other side. Next set of redundancies we have is actually in the controllers for the storage. That's the 3rd and 4th item on rack 0. Again, full redundancy. So if one controller fails, the other controller is automatically operational, and it's balanced. It's both are in use at the same time. From the server side, the next piece that we've got that's on the redundancy is the Ethernet connections. So we've got 2 NICs in each server, or dual port NIC in each server. And again, we're running those to 2 different switches. You can see at the top of racks 1 through 4, there is a Cisco switch in each one. And so we will take a Ethernet connection from this server and run it to the top of rack 1, and then from the second port in this one, we'll run it to the top of rack 2. So if we lose any one switch, everything is still connected with the second switch. I believe, as we did our analysis, we've only got 2 devices that have single NIC in it. One of them is this point of sale system. So we're pretty well covered there. And then the other redundancy coming out of the server is dual power. Dual power was kind of fun. It was a project that we updated less than a year ago now. But you'll see down at the bottom of your drawing there that there are 4 circuits at the bottom of each rack. There are 2 circuits, or basically we have 2 different circuit panels in the server room. So 2 circuits are going to go to panel A, 2 circuits are going to go to panel C. What we do is we make sure that when we're dealing with a server, we'll take one power supply and it gets tagged to a circuit on panel A. The other power supply gets plugged into a panel on, or to a circuit on panel C. So again, we could lose an entire panel or an entire UPS, and that's the other piece of this is we have multiple UPSs back there as well. So panel C is into 1 Liebert UPS, panel A is into a second Liebert UPS. I could lose an entire Liebert system and still be providing power to all of this gear through the other Liebert system. That was a long night. We started at 10 o'clock and we didn't finish till 7 o'clock in the morning of power down the entire thing. Windemuller Electric was in, ripped electric out, making all those changes. But that's the latest thing that we did. Actually, we did that in conjunction with the VDI because of not only are we going to be providing services for ourselves, but we'll be providing services for TCAPs as well. Then the other piece actually on the power, if you remember from our tour day, is all of the power is backed up by a natural gas generator. So again, just kind of back it up as far as you can, as far as the control that you have, to make sure that you've got as few points of failure as possible. The other redundant piece that we have would be in our ISP, our network internet service. We've got 2 ISP providers that we work with, both Merit and Charter Network. Both of them access campus from 2 different ways. Primary way is in through Front Street at the stoplight. There is a secondary path that comes in through the Eastern Avenue entrance down by the Beckett building. So if either one of those places experience a backhoe dig, we have a second way on and off campus. As far as the hardware redundancies, that's probably in a nutshell what we've got going on. Scott preloaded me with a couple questions that I've got answers to, and then if you've got questions, please shout them out as we're going through. One of the questions was how many servers do we need in the quorum to keep the cluster alive? And when I posed that one to Bryce and Neil, they went, good question. The answer to that really is more not the number of servers, but the load and the ability to load. If there's no load on there, I mean, we could have a quorum with 1 or 2 servers. Our load right now is very light, even with 8 servers. I don't have it. I can show that to you, but Bryce sent me a quick snap of what the CPU load was, the RAM load on the 8 servers that are running, which now I know why they haven't really gotten the other 2 in as fast as they want, because it's the load is we've got a pretty healthy system for the amount of load that we generate. So as far as a specific number, I can't tell you that. It's really dependent on the VMs and the load and usage that's going on at that time. How things are determined where they fail, or what happens when they fail, I guess is probably the better way to look at it. So basically, we lose a vhost server. We lose a vhost 2. All of the virtual servers that were running on vhost 2 are scattered out to the remaining servers, the physical vhost servers in the system. With the compellent and the VMware system that we've got, basically we implement something that's called Distributed Resource Scheduler, or DRS. Basically what it means is VMware is taking responsibility and control as to what goes where. So we lose vhost 2, it's going to look at everything that was there and say, okay, based on what's going on, this is where you go. And we do nothing. It just happens in the background. It generally takes, a minute, maybe 2 minutes for whatever was on that virtual that was on vhost 2 to now pop up on vhost 4 or 9 or whatever. And for the most part, anybody that experiences an outage, it's going to be a blip. It's like, wow, got really slow. Oh, never mind. But it's all designed and scripted, so it comes back without intervention from any of us.
So in real day-to-day production, how often do you deal with failures, either hardware or virtual?
Rarely. We've had our vhost and compellent system in play for 5 years. And actually, as Bryce and I were looking over this last night, he says, I can't remember the last one. I can't either. I can't remember the last time that we had an unplanned failure. There will be times that we want to do something to a server, and so we'll fail it. But
When you fail each individual VM, say you go here, you just failed the node, and then
depends on what's running. Depends on what's there and the comfort level that Bryce or Neil has with what's there. They've done it both ways, where they'll fail the virtual, or they'll just fail the whole box and let it scatter.
Now, when you say compelling failures, you haven't had one. I'm guessing you have lost individual disks.
We do lose disks, absolutely. Just lost one this week. But with the system that we've got, if there is a disk failure, the first thing that happens is we get a notice from Compellent. Compellent monitors our system 24/7. The Dell Compellent company. It's part of our service contract. So if there's any kind of failure or a warning or anything that pops up, they're notified of it, which then they will in turn notify us. Some of the service issues, we'll know about it before they do. But others, especially like hard drives, unless we happen to be in the management console at that time, we wouldn't see we don't see the failure notice before they do. And so they will send us an email notice, hey, hard drive such and such has just failed. It's all automatic, and we'll make contact with them, and they'll run a couple tests. Yep, it's dead. Have a new one tomorrow. They'll ship us one out. We'll plug it in. We'll contact them, say it's in, and ship the old one back.
You have hot spares that will rebuild in the meantime?
Yes, absolutely. We've got two hot spares in every shelf. So the rebuild happens when you put the new drive in. They go back in, and then they will initiate the rebuild again.
Become the new drive, or does it become the new hot spare?
It becomes a new drive, and the hot spare is back to a hot spare. If there is, especially in the compellent system, if there's a larger failure, if they saw a controller failure or a massive failure, then it's a phone call, and it doesn't matter. 2 o'clock in the morning, there's a couple of us that will get a phone call that there's a problem. In the 5 years, I've only had one phone call from Compellent on what appeared to them to be a massive failure, but actually it was a network communications issue. So everything was running.
Are you guys responsible for firmware maintenance updates on the controllers, or is that something they took care of for you as part of the
It's a joint. Basically, they don't do anything without us, but we always work with them on it.
Does that happen very often?
No. No. Nope, sorry. Joe.
I kind of just a question, actually, you're gonna hate
I already do. That's okay.
first of all, what was the cause of the network outage we had about 5 minutes last Wednesday?
Not determined. Yeah, the one that you called me on, I'm not determined. I have no idea what happened there.
And then the second part of that was how, what troubleshooting process do you go through to find out the solution to it, kind of a self-fixed problem like that, or how important is it to know what, caused it?
It is important to know what caused it, and really at that point, the only thing to do is to start going back through logs and see if we can determine anything, what was going on at the time. Was it is a server issue, storage issue, or it could be in this case, or in that case, it could be an issue with the core switch. Could be an ISP provider. So that one is up in the don't know category. Hate those.
So we talk about Hyper-V all the time, but it seems like VMware is like the dominant platform, or at least places that I know about use a lot of VMware. How do you make the choice between the two?
For us, VMware for us is the dominant platform.
I can
It's
help on that one.
okay. Go ahead. And for us, we did. That's where we just started in.
Windows servers, they have no doubt.
True.
So when you start looking at which virtualization platforms, you can either buy VMware and put it on a Windows box or a Novell server or a SUSE Linux or whatever you want to run it on. Or it's a feature of the operating system with Windows. So if somebody is a total Windows shop, they've already paid for the virtualization component. So, and over time, Microsoft actually, and I'm not pushing one versus the other, okay? Don't think I am. Smiling at me, no, but they do try to do this to each other all the time. Okay, I mean, there are times I've seen Microsoft come out and say, we are now faster than VMware when it comes to IOPS. We're doing over 1 million IOPS with regards to transactions and so on, and VMware can't cut it. Well, then next thing you know, there's features and functionality inside VMware that totally blows Microsoft away. I mean, some of what he mentioned a little while, I'm sure he'll talk about is this automated system, what you call it? Is that?
DRS.
Yeah, DRS. I'm not so sure that Hyper-V can do that as efficiently as what he's talking about. The idea of having closely resembled physical hardware. I know Hyper-V is a little more forgiving with some of that. So with those things, it is a tough decision. For small to medium businesses that already have the investment in Windows, it kind of becomes a no-brainer unless they have somebody that came from a VMware place that knows a lot about it, can jump in, hit the ground running, and for a little investment, get Hyper-V up and running.
Yep.
So it's a tough call.
So just
And-
as an aside, considering how ubiquitous VMware is, do you think that NMC would ever offer some type of class as part of this infrastructure degree on VMware?
Remember last week we talked about how the fact I want to change some of the way this class is structured next year? I want to do some of that. I want to remember I said I want to make it more project-based? One of the projects is going to be more than likely implementing a failover cluster under VMware, because I can get the VMware license, I believe at no cost, for a standalone type of box, and then do clustering of VMs. And we may be able to have some connection through your agreements and stuff, or, I don't know, on the educational side, we might be able to get licenses and teach.
Could, yeah, something to investigate.
I'd like to at least introduce that as a topic. Here's how Hyper-V does it. Here's how VMware does it, so you get a little exposure, not to make you gurus in either one of them.
Sure. I've never even seen the interface.
Well, you can actually download VMware Workstation, put it on your PC instead of VirtualBox, and run it all day long for free. So, but
For-
yes.
For NMC, Scott's right. At the time we jumped into this, none of our physical servers, our major physical servers were Windows servers. We had a few minor, but none of them were major. All of the VDI servers, the vhost servers, the banner servers are either Red Hat Linux servers or SUSE OAS Linux servers. That's our host platform. Now inside our vhost platform, yeah, SCAD's a Windows servers. But on the outside, they're all Linux boxes. I think
What's the result of the transition where we came from? Had those been Windows boxes, maybe a different picture.
could be.
People that you have working here have to be pretty snappy on both, huh?
On both Linux and, yeah, Linux and,
And here's the story on that. I remember when Bryce was learning SUSE, trying to get because Novell was a NetWare platform. NetWare was not SUSE. NetWare was NetWare.
and NetWare was on the way out.
What's that?
And NetWare was on the way
It
out.
was on its way out. And so if we were going to continue with them as a vendor and a product, we had to migrate to SUSE. Bryce knew that he had to learn that. And this came from him directly. He said, here's what I did. He said, I took my PC that was running Windows because I had to have that to support all the end users at the college at the time. He said, I wiped it clean, put SUSE on it. Forced himself to learn Linux as his host OS on his PC. And then what he did is he set up VMware and put Windows on it so that when he did have to support an end user, he'd jump into Windows to do what he needed to if he couldn't figure out how to do it through the host. So he forced the learning curve to learn the product by doing it that way, which I thought was a really cool way, because if you're not doing it every day, you're not going to learn. But if you force yourself, yeah, it took him a while to learn how to do things that he had never done before, but he always knew he had that escape plan. If he had to, he could jump into, if it was a critical issue, he could jump into Windows and take care of it.
And for those of you who don't know who Bryce and Neil are, that's who we've been talking a lot about, both of them came up through the NMC system as students. Neither of them have done this job anywhere else. So they all started here. I think the last thing that you had on my list, Scott, was...
Make sure you show them that thing you were showing me with the cloud and
Yep.
how one
Yep.
fails it.
Oh, yeah, okay, yep. Before that, snapshots, backups, or in the compellent world, they're called replays. And so Scott's question was, snapshots? Yeah, we do snapshots. Next. No, we do snapshots or replays. The most common replay we do is an hourly replay. So basically, anything that's out there, every hour it's getting a snapshot or a replay of it taken and stored off on an hourly basis. To have the ability to go back a short amount of time to fix a problem, obviously very desirable. So our scheme that we work is between business hours of 7 a.m. and 11 a.m. We're doing business snapshots every hour. Those snapshots stay live for 24 hours. So the one that is going to be taken here at noon will be live until noon tomorrow. At what point at that point that one drops off. There's also a nightly snapshot that's taken that is kept for a total of 60 days. We keep it for 7 days on the primary system and 60 days on the DR system. And then those drop off automatically.
The majority of the data that's stored on the redundant SAN is snapshots that
It's all that's on the redundant SAN is snapshots, backup snapshots. There's nothing else on there.
Let me ask you one last question. If you have a snapshot you need to go back to, is it an all or nothing thing?
No. What? I hope I get this all right. So basically, if we've got to go back to information, if we've got to get some information from a previous snapshot, what they'll do is they'll take that snapshot and they'll build a
Moving out?
yeah, there's a term for it, and I lost the term. But they'll build a new VM. So let's say that it's drive N, where the data classes information is. They'll build that in a temporary location, and from there, then they can get the information restored that they need, and then they'll kill off that VM. It can go granular down to a file. It's just the process that it takes to, depending on the size of the volume that needs to be brought back, how long it takes to build that.
Two types of snapshots. One of the actual data storage itself,
Mhm.
and drive,
Yep.
but then also a snapshot of the VM that's running at that point in time.
No, just we don't do snapshots of the VM running, the live running VM, just the data. If I got that wrong, Bryce, tell him. No, I'm pretty sure it's just the data running.
Just the raw data.
Yep.
So that you
Yep.
can go into like a previous version of whatever folder and pull out.
Yeah, exactly.
individual files.
Pull it out. With the system, yes.
I just had a question about doing a recovery from that situation. Is that really the most efficient way to do it, to spin up a VM just to recover data from one spot?
It is, because it can happen without anybody else knowing it. If I've got to find something for you, I'm not going to impact anybody else while we go grab that file.
I know, like Macro, for example, allows you to take a snapshot and mount it on a specific file and then export that back out.
I'm sure.
So as far as resources are concerned, to spin up a whole VM,
I'm sure that's great.
There's that piece, I believe, is in there. As far as to what level they've got to do it, I'm not exactly sure.
So when he says snapshot, what's that comparable to? Shadow copies, exactly. Okay, now, that's different than being in Hyper-V and saying, having a running VM and going, I want to snapshot the VM. Because that does is it takes a picture of that VM at that point in time. So that's why I asked him the question, are there two different types? A snapshot of the data, which would be Ryan shadow copies, and a snapshot of the VM itself. I don't do very many snapshots of the VMs unless I know I'm going to do maintenance, like I'm going to do Windows Update, and I don't want to have to screw it up.
Right.
But-
And we can do that on a manual basis.
Okay. Yeah, and that's so, just so everybody's clear, I think we are talking two different things.
Yes.
And each of the providers has a solution for each one of these.
But doing live virtual backups, VM backups, that's what we don't do.
Just out of curiosity, how does that snapshot system come to play with like security or deep freeze for the college? Is there any interaction whatsoever? or-
No, it doesn't, because deep freeze is an application that's on the workstation. And Secunia is actually workstation based as well. So the snapshot doesn't have anything to do with it. Snapshots are only taken on information that resides on the SAN itself, nothing out at this level.
So if you don't take snapshots of the VM, what happens if like a whole rack dies or something? You have the data offsite somewhere that you can store it?
Here,
That's what's downstairs.
Remember,
That's what's downstairs.
They're on the sand. So they're already there.
Yeah, I mean,
They have snapshots of the, so while they're not taking a snapshot of the virtual machine, they are taking snapshots of the disk files that the virtual machine is using.
yeah, I could lose a rack.
It's kind of into, Jeff sent me a question earlier in the week, and I'm not picking on you, but it was very interesting, because the terminology just does one of these things. I mean, what's a node, what's a cluster, what's a host, what's a snapshot, what's a, all of that stuff. And that's why this stuff is not easy, is because it's hard to wrap your mind around, okay, and this, are they, and especially if you go out and you start finding resources on the internet where you're using these terms, and the people that are providing the information may not be using it in the same context as the other person is. So it's like, are they talking apples to apples, or is it, this guy is calling a node this, and this guy is calling a node this? and you're trying to wrap your head around thinking it's the same thing. It's not easy. Look at this.
How do you guys approach logging off the servers? Because I know we're trying to log on the machine. I don't know how you guys approach it.
There is basically right now the logging that happens is base default logging. I mean, we've not been doing a lot of extra logging as far as what happens, but that's actually a project that's on our table right now, is to look at logging across everything, not just the servers, but across the entire infrastructure. So it's one that's on the table for if nothing else, for a redo. This is a picture that was taken of the vhost system running at some point. Not really sure where this actually. If you look, you'll see there's only vhost 1 through 9 there. But that's really what it looks like. You'll see, pick any server, and then you can see the different servers. Oh, this is old. This is an old snapshot. Move away from that one. You'll see the different servers, the virtual servers that are running off any single vhost physical box. So we've got like I said, we've got 120 of those out running now.
Where do you see the highest loads? Like which servers are utilized the most?
Because DRS is managing and balancing that, we don't see it. They just they put it where they say this makes the most sense. This is where you're going to like it the best.
And so what he was explaining to me is if this vhost dies, all of these guys, it just goes
Poof. They'll scatter.
where they need to go.
Yep, they'll scatter to where. So that's why a picture like this was good at that second. The likelihood that you're going to get that disbursement again, not going to happen. A couple other things I wanted to show you as far as infrastructure that kind of dovetail hand in hand with infrastructure is monitoring. We've got a couple different monitoring systems in play that we use. Primary one is this one here. It's called Nagios. And what it does is it sits there and it monitors the health and life of all of our gear. So you can see that right now 268 physical hosts, 329 service checks. That's what's happening all the time. On a physical host check, we are, let's see, service, okay, host check. Host late, you can see some latency time, 0.03 seconds. What we're doing is, of those 268 devices, we're sending ping tests to all of those every minute.
Okay, so this is not only servers, it's switches, it's any of the physical devices that
Yep.
they want to make sure are up and running. And as well as logical devices that might be VMs that are running as well.
Exactly. So it'll send a test out to a specific box. If it doesn't come back in the proper amount of time, it will test it 2 more times. If we get 3 consecutive failures, then we get pages. We start getting notifications.
Now, I have a question about that. Is the notification process housed on your system such that if it's down, you won't get it's down in conjunction with another piece of equipment, you won't get paged? Or is that done through a third party so that no matter what happens, you'll always get a page if something goes down?
This is done through our system. So the only way that we don't get a notification is if the Nagios system goes down.
That's what I guess I'm doing.
And we actually, that happened once. When we lost power to the data center and the generator did not kick on like it was supposed to, the batteries in the UPS went dead in about 12, 14 minutes. Happened on a Sunday afternoon. I'm sitting there, actually sitting in church, and all of a sudden I start getting notice, switch down, switch down, switch down, and it's like, oh, we had a power failure on campus. You can see it just rolling through my pager, boom, 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 and all of a sudden it stopped. It's like, hold it, I should have had a whole lot more pages. Waited, what happened, what happened, what happened? Long story short is the generator did not kick on. Everything went dead. The only way that I could determine at the time what had happened, without actually before I could get there, was let me call my office phone, see if voicemail picks up. If voicemail doesn't pick up, my server room has got no power, and that's exactly what happened. So yeah, if we lost our Nagios box, then we would lose this piece. Neil's in the process of redoing our entire Nagios system into a virtual configuration instead of a physical configuration, so we can get a little bit more redundancy built in there. At one time, we had a piece built into it where we had a device sitting out at the observatory, and its sole purpose was to see if it could communicate with the Nagios. And if it lost the communication with the Nagios, then it would notify us. But they got a little squirrely on us, so we backed away from that. Joe.
Just out of curiosity, how do we determine the backup battery life? I mean, is it based on response type of attack? Is it based on
In the server room,
Yeah. I'm just thinking 14 minutes in, so like it was, I know
it's
it's a generator.
it's absolutely not enough. Our backup system is the generator. It is not the battery backup at all. Battery backup in there is for power conditioning, and for the 60 to 90 seconds it needs to spin the generator up if there's a power failure. For us to have a battery backup system that would keep the server room operational for an entire outage, I would need a building.
And lots and lots of money. So
Yeah.
the question is, what you use to determine it, you figure out what the load is that you have to keep it running for a few minutes, and anything larger than that, you're gonna pay lots of bucks for it. So it's really, what can you afford? How much power can you afford to have? As a backup.
So different pieces in our Nagios system. I mean, they have identified different groups. You know, list of 80 related servers, CIT servers, and then some of the statuses. You'll see here we've got 38 that are up, 2 that are down, but they've been acknowledged. Yeah, I know they're down. We've got them down because, and so they're an acknowledged down. This.
Infrastructure is virtualized too? Like, do you host DNS in a virtual machine, or
DNS is on a physical machine right now, DNS 1 and 2, but DHCP is on a virtual machine. So here's some.
What about LDAP servers? Or AD?
AD are on virtual machines.
That integrates in with LDAP, so
Here's a overview for some different of the services as well. So at any given moment, we can take a quick look and see where things are. This is how I've got one of these running on my desk, and this is what I sit and see. If something dies, it's gonna show right here. If we have a service problem, it's gonna show right here. So that's what I see. A couple other pieces that I monitor is how's our bandwidth, or how's our network traffic. So this is our on-campus, off-campus on our Merit. This is our all wireless, which is our charter system, our charter ISP. Charter is we use Charter to provide ISP services to our residence halls as well as all of our wireless. So this is all wireless, and this is our ResNet, and there's more graphs down there, down lower. Then one of the other ones that I keep an eye on is this is our what Merit calls their weather map. So you can see the legend over there, and what is the percent of bandwidth usage at any given minute from Merit. If we're starting to have problems with performance, I can go out here and look, and I can see, if we've got a lot of, oranges or reds, we've got problems.
So where's the connection to you? Where's NFC?
We're actually, it's here. This is,
Tied to us too?
Yeah, oh yeah. This is not the physical. This is more of a virtual representation, but there's actually a large pipe here, and then distribution from there.
But your main focus is.
And yeah,
if they're
and
having
it
something-
goes
If they're having a major problem in Chicago, then it's gonna have some sort of.
exactly,
effect to you.
or East Lansing or Detroit. This actually goes up to the UP, across that way, and then back down to Chicago. So our paths are to get down is this is a primary, that's a secondary path. And all that's telling it, this is definitely not showing every merit connection. This is the major pipes. So this connection right here is generally, running almost no load because it's more of a failover connection to go to the UP if we have a problem coming down.
So is Merit using, like, AT&T as the backbone services, and Merit manages it, do you know?
They
Merit own all the fiber?
no. Merit owns fiber here, but no, Merit does not own all their own fiber.
So it's all going through some sort of telecom infrastructure of some sort.
Quest, AT&T, other service providers.
It's always kind of around a central, major population zone, we can, work off that a little bit. Just out of curiosity.
What's
It seems to me like the central hubs are always in, Chicago, Grand Rapids,
Oh.
the bigger cities. Does it have to run at bigger cities? Do they ever do anything different than that?
I think it's because of the population zones.
I'd say it's based on demand.
Yeah.
They're gonna place the resources where there's demand.
Trevor, for Merit, Traverse City is actually a pretty vital piece to them because they jump off our services. They use our services then to cover this whole part of Michigan up here, the upper east side.
I have a question about the VDI versus like deep freeze.
Mm-hmm.
Like I said, at the hospital, they do this virtual desktop thing, and from my perspective, it's a lot of logging people off, terminating processes that are hung. There's just a ton of that. So
Really?
yeah, I'm curious why you would go with that versus like deep freeze on the workstation and then maybe the networked application delivering it that way.
Deep freeze on the workstation, we've been running deep freeze for years and years and years. Works marvelously on the workstations. It keeps our workstations clean, especially the ones in the labs. The biggest problem that we have is adding information to the computers in a computer lab after semester started. We will run crazy from May to August getting the lab set.
Go ahead.
Then we come back and instructors will come back and say, hey, I found this great cool piece of software and I got to use it with my class. It's legit, okay? I mean, these guys have been out in the summer. They're prepping, they're exploring. Yeah, I'm still in the dark basement. So, but they'll come back with I want this new stuff. Okay, some of them knew it ahead of time, but that's beside the point. So we've got to get back into the lab and load that software out. Some labs are impossible, literally impossible to get into. Just they're booked all day. With the VDI setup, we can do all that in the back end. We'll take and add that application as a layer. We'll test it. We'll do everything we need to. When we're ready, we'll publish that layer, generally overnight. That layer, that application layer will get published. You log into your thin client the next morning, it's there. And we've not had to touch this room physically at all.
So with the deep freeze setup, you have to physically, so you can't push it out through AD, publish it like a MSI or whatever that is?
You have control of that, some controls of that through SCCM and the ability to push applications out. Not that easy.
Well, and here's the other issue. Last I knew, SCCM, System Center Configuration Manager, is limited to MSI installed. Not every application is based on MSI.
And as we're finding, not every application is going to play nice in the VDI world either. So there'll be some places where we will have traditional CPUs, fat clients, and other places where we've got the thin client boxes. For us, it is not going to be a fits-all deployment. It'll be where it makes sense. The other thing is useful life. Generally, we go about 4 years, maybe 6. If we've got a couple places where we stretch. So we got 4 to 5 years though is what we have for a useful life on any of these desktop devices. The projected useful life that we've got on the thin clients is going to be in the more in the 7 to 8 year range. And we're on the conservative side of what the industry says, which is 10 years. If we get 10 years, we're going to look like heroes. If we get 7 years, we're still going to make out well. So you never get into VDI to save money. The amount of money that we've got sitting back here. Can I give me my picture back? The amount of money that we've got tied up in 12 servers and all of the compellent stuff, huge. As an example, the boxes that they delivered, the 2 SSD racks, the shelves, the 1 SAS shelf, and some of the Brocade stuff. They delivered it to my office. And there's 3 boxes, about yay long, 3 of them stacked about that high. The cost for those was a little over $300,000 for those 3 boxes. I knew that because I'm the one that did all the work on it. One of the guys in my office kind of brought it all home. We're standing there. He says, "That's a pretty doggone nice house." It's like, holy cow, you're right. So you don't jump into this because VDI is going to save us a ton of money.
Well, and he told me before class, the backup SAN that's downstairs, all the equipment in it is 5 years old, end of life. There's 84 terabytes of storage there.
We've got to do something different the next year downstairs. Where we're going to make our win with VDI is to be able to provide a better product and better service to all of you.
If I don't get my grant, I know where to go.
If you get your grant, I know where I'm going. I have a master key. Now I can start come stealing from you.
This VDI, I'm guessing this probably isn't as much of an issue today as it used to be. But does VDI play well with things like USB dongles, that kind of stuff, where it's attached to a physical box?
In theory, we're going to be finding out. There's some applications that we're going to have to take some work on to see if it's going to play nice in the VDI realm. There's places that we know that we're not going, at least right out of the gate. We're not going to go down to the CAD lab.
Yeah.
We're going to leave that one alone.
Yeah. It's blowing up, getting a profile.
So we're going to be careful where we go.
So our 20 minutes has turned into an hour and 5, under an hour and 7.
I knew I couldn't do it in 20.
Any other questions for Dean?
Yes.
So the whole point of the whole thing is to get high availability, right?
Yep.
So with all of this, it would seem like when you system make something real, you wouldn't have to announce that. Is it because of development, or is it because you have to shut the whole system down? Or
So when we're doing system maintenance on Moodle, what we're doing is we're actually taking that Moodle virtual server and applying the patches, the update, the whatever. There are actually, I believe there's 3 Moodle servers. There's a test, there's a production, I think there's a dev. So there's multiple Moodle servers out there, but the one that you see, after we've applied that patch and tested the daylights out of it in test and dev, now we got to get it into the prod server. And the only way to do that is we got to take prod down. If we had 2 instances of Moodle and they could both be live at the same time, but that's in most cases not really realistic.
And another aspect of that is the maintenance itself. If you look in chapter 2, they talk about cluster-aware maintenance from the standpoint of, remember, the hardware and everything's got to be somewhat similar. They got to have the same Windows updates on them and things of that nature. If you apply to one, it breaks the other. And so there's ways in which you can actually do it where the cluster-aware maintenance handles it itself, or you can do it remotely from another box outside of the cluster and initiate it remotely where it'll do one node, but it updates the other. So it can be initiated by you or unattended. And that's something 2012 can do, but it's still an issue, and I imagine they have the same thing. Some of these hosts have to be updated with maintenance or patches and stuff.
Yep.
They have to break down the machines. And virtualization is great. It provides lots of opportunities. You can, Doug talked to me a lot about it. He says, just to think that I can run a machine on a machine, so cool. Yeah, well, the more VMs you have, that doesn't make the maintenance go away.
No.
It just compounds it, if anything.
Now, if we've got to apply maintenance to a vhost, sure, we can fail that box off, scatter all the VMs to the four corners, and apply maintenance to that, and then put it back in the queue, or put it back in the system, make it available, and go to vhost 9, fail that one off.
When you're talking about the Moodle server, are you talking about the Moodle cluster? Or are you talking about, like, there's one virtual server that's running Moodle? Right.
You're not doing load balance.
No, we're not doing load balance. There's one Moodle
One VM.
production VM server.
And again, I'm pretty novice at this, but I mean, this whole thing is about high availability and everything, fault tolerance, and arguably one of the, I would imagine, busiest applications that the school is running is only sitting on one.
But
Same with our ERP box. Our ERP box is actually the busiest. It really boils down to, I've got this much to spend to be able to do this. And to be able to make it high availability, load balancing between multiple devices, dynamite. But that means then I can't do all of this.
But really, think about what you're asking, though, because here's the thing. They're not doing load balancing. So in other words, they don't have two Moodle servers where it balances the load between them. They have one. And you're saying with something that critical and that big of a deal, if it fails, shouldn't we really be looking at having high availability? They do. The data files for the VM are on the same.
So if the one.
So if it fails, it'll fail over to another physical host.
It'll fail. Yeah, it'll fail to another physical host. Yes, but if there was a corruption in the Moodle,
A new VM somewhere else, and all the data is on the same, so it just starts running somewhere else.
no. If I understand what you're saying right, if we had a corruption in the Moodle application, the Moodle software, that would take the Moodle server down. If we had a problem with the vhost that's hosting the Moodle server, and the vhost went down, Moodle server is going to go find someplace else to live. So the only thing we've got to be that we've got to be really careful with is that corruption within the virtual machine itself, and that's why all the testing is done on dev and test before it's applied to prod.
Yeah, as long as there's no issue with the virtual machine itself, it can fail to any physical node because the data files are on the same. And that's the cool thing about having the shared storage. There's two terms you'll hear throughout your book: high availability and something that's continuously available. Okay, so one provides redundancy for failover. Well, I guess they both do, but I mean those are two terms that they'll use throughout the book and for a couple different things. But we do want to look at high availability.
Joe.
Just out of curiosity, how do you budget for end-of-life major equipment for a large institution? I mean, do you pay an installer installments? Do you hope you get some
I'll
money
leave
back?
on this one.
Payroll deduction from Scott's check. No, there's actually, I've got another spreadsheet out where, for servers specifically, I've got things planned out to fiscal year 23, which is 2024. So for all of my servers, got a list this way of what they are, and then when they were put in and when they should be replaced, and the amount of money it costs every year based on current cost for those servers. And the same thing with the storage. I mean, you go into a storage knowing that, yeah, I'm going to get somewhere in the 5, 6, 7 year range. The reason why we have to replace everything downstairs is because we've got older controllers downstairs, and we've got an older shelf. One of these shelves right here, this shelf right here. Downstairs, that's all it is these shelves and the old controllers. My replacement plan could be that I put a pair of current controllers, SC8000s, and SAS shelves in and migrate everything over. Pardon? Oh yeah, it's new discs. Yeah, it's new everything. What I've got to determine, and I being there's a group of us, but what we've got to determine, is that the best way? This system's dynamite. I love it. It has saved my back so many times. It's expensive. So from a backup perspective, is that the right system to have downstairs, or can I have a different system that may be a little bit less expensive? If I were standing here talking about the primary system, yeah, I'd fight tooth and nail to keep that.
Because cloud-based solutions are becoming the DR for a lot of organizations.
Yep.
And some have said our primary data center failed, everything switched over to the cloud, and they're questioning whether or not they really need to
Bring it back.
rebuild
Yep.
the primary. Could it be the backup because the cloud services are working so well?
That,
Well,
that
one of the things you brought up is something that's important for every organization. The college, as well as most businesses, will have what's called a master plan, which deals typically with facilities and those types of things. Well, it was, how many years ago did they make you develop the technology master plan?
Wasn't that long ago.
Included ideas of how often do we have to replace equipment, that kind of stuff.
Yep.
When you initially started, there was never that.
No. One of the, like I said, we've got to figure out what we're going to do to replace downstairs. One of the options that is definitely on the table is cloud-based backup utilizing Merit Networks and their large infrastructure in Ann Arbor. That is it's a viable option.
Just have a question about the accounting system that you've got in place here. Did that replace existing gear that could have been migrated over here as a backup solution that maybe was older gear?
Most everything that I've taken out, Scott's stolen.
Back through.
Whenever we do a tour in East Hall, it's like, okay, position, buddy, pat down. We got to make sure.
He's trying to figure out how he can get the backup sand at his house so he doesn't have to heat his home anymore.
It would. Yeah, we a lot of our gear that we take out of cycle. Yep.
And like I said, if my grant doesn't go through,
If his grant goes through, he's gonna have better stuff than I've got.
for a while, 7 years maybe.
Yeah, there you go.
Anything else? I want to get you guys in your project.
Only 20 minutes, right?
Can we give, what'd you think? Is this good?
Yes.
You know, I noticed they pay more attention to you when I'm up here.
It's because I don't grade them.